This is a tutorial video for Make. I will show you the usage of Make with several examples. But firstly, I assume you have never used Make before, and you are familiar with some shell commands. The first question is, why do we need Make? If you are developing a project without a powerful IDE, how do we build or update the project automatically? It would be too tedious to explicitly call the compiler each time, so we need a tool to clarify the dependencies and building rules for targets. And this tool is Make. See the image on the right. We have many source files. And how can we build the target file? So we need an automation tool to help us build the project automatically. So that's why we need Make. Make is a build automation tool that builds executable programs and libraries from source code by reading Makefile, which specify how to derive the target program. It is widely used in Unix-like operating systems, and simply, Make is a shell command. If you have a Linux system, you can check your Make version. Most of the Linux system will have Make pre-installed. In case your system doesn't have it pre-installed, just follow the instructions. Now you are free to use Make. So, Make is not a compiler, but it could add compilers or other tools to finish specified tasks. And we need the Make to build or update the project. Also, you can use Make on Mac OS. So what do we need before we use Make? To let Make know what and how do we build, we need a script file. Typically, it is named as Makefile or the small m. Make sure there is no extensions, just Makefile. The script file is written in a specified Makefile language, but it will be easier if you are familiar with the shell commands. Once you execute Make, it will find this script, otherwise report a vital error message. But we can use alternative Makefile by specifying the argument f. Make will treat the file name as Makefile. It is useful when you want to preserve different versions. For example, there are two versions of Makefile, and we can build different projects based on different Makefile. Now I'm going to talk about the rules. Makefile consists of a set of rules. These rules determine what are the target files and how to make them. A rule generally looks like this. We can see there is a target part and prerequisites. And below there are commands, a set of commands. And remember, there is an indentation before command, and this is crucial. Targets is the target file we need, or some intermediate files, or some actions. And what is actions? Actions could also be called as phony targets or or label, which will be introduced in later part. And the prerequisites part are the things needed before making targets. For example, we need main.c to make main. Main.c is a prerequisite, and there can be more than one prerequisite for each target. Finally, there is the command part. The commands to create targets or other shell commands. The command does not necessarily create a target if the target is not the final target or prerequisites of other targets. This means the command may just only do some actions. They do not produce any target files. Target part. Specifying a target tells make there is a rule for the task, and not all targets will be made. By default, only the first target in make file will be made. And you can see in this image, there are two targets. One is main and the second is main-1. So if we type make in the shell, make will only build the first target. Or we can exclusively tell what are the final targets. So if we type make by the two targets, all the targets specified in the command. And there is a special kind of targets called actions or labels. These are the targets that will not be produced, but only actions. And you can see in the screenshot below, print is the label or action. It only echoes a sentence. No file called print will be produced. And then the second part is prerequisites. Prerequisites is very important in Makefile. Prerequisites are everything needed for a target, also known as dependencies. And they are not necessary, especially when a target doesn't need anything beforehand. Once a target is being made, make will check all following prerequisites, and if any of them is missing, it will find a rule to make that prerequisite. Actually, it traverses through the dependency tree and eventually builds the final target. A prerequisite may also be a target. In the image on the right, main.o and func.o are two prerequisites for main, and also they are targets themselves. So in this case, the rules for main.o and func.o must exist. Otherwise, make wouldn't know what to do when it can't find them. The third part is the command part. This is a set of commands. Tells what to do when the target is required. They can be shell commands, and usually it calls some compilers to make the target. But it can also look like the screenshot. They're also legal. You may notice all executed commands are printed when we type make. This is because make will echo anything it does by default. And we can disable this function. Use the argument s. What if we have many targets to make? one possible solution is to type make target 1, target 2, and there is one common solution. Define an extreme target, usually named as all. Actually, it relies on one basic rule. Always try to complete the prerequisite. All is the first target, so when we type make, it will make this target, which is all. And min and min-1 are considered as prerequisites. To complete this prerequisite, make will automatically finish building these two targets, so we can get what we want. So we have 3 subtasks here. Extreme target all. We can finish all the subtasks by one single command. And notice this @ mark is a trick. It can prevent echoing the command. So after finishing the subtask 1, it will only print subtask 1 is finished, but not repeat this command. We only type make, and all the subtasks are made. Now I will introduce the mechanism behind make. First, make will figure out the true targets, which can also be called final targets. Second, based on the prerequisites for the true targets, build the dependency tree. And this is a recursive process from the top to the bottom. You may see project depends on the 3 object file, and each of the object file depends on several source file or header files. Make will build targets based on the commands from the bottom to the top. So make will find the data.c, data.h, all the header file and the source files to make the object files on the second level. And finally, use the 3 object files to make the final project, which is project 1 in this example. If make fails to find the rule for some prerequisites, then it will abort. So be careful with the script writing. Make sure we have enough rules. For example, if we don't have the rule for data.o, makefile will not know how to make this file. So makefile will not successfully build project 1. And there is an important mechanism. If the final targets are up to date, they will not be made again. But how do we know they are up to date? If the prerequisites are up to date, then the targets are considered as up to date. Again, it is a recursive process. If one of the prerequisites is newer, make will only take care of that. This avoids useless efforts because it only updates when needed. If we want to force make to complete the whole process, whether it's up to date or not, we can use the argument b. So now all the basic rule for make and makefile is clear, but there are also plenty of fancy stuff which would make it easier. I will introduce them one by one. We can define variables in the makefile script. Define a variable directly by the equal symbol or a colon followed by equal. we can use the defined variable by a dollar symbol and a curve bracket. Makefile will substitute all variables when executing. And there is an example. Both variable names and the values are string. There will be no calculation, only substitution. So in this example, we define object equals to main.o and func.o. So in line 2 and line 3, objects will be substituted by these two object files. I have defined three variables. Variable 1 is a simple string, says I am a string. And variable 2 is a target list. And variable 3 is initialized as variable 3. But we can use the add equal like the syntax in C++. Combine two variables and guess what will happen when we execute make. If you are correct, then you fully understand the variables in Makefile. And there are several automatic variables. Automatic variables is a special kind of variables based on each rule. Each of them have special meanings. With automatic variables, we can modify the target name without carrying the commands. And here is another syntax called wildcard. There are two kinds of wildcard. The first one is star. Star matches file names in file systems, return names separated by space. Often used to connect a set of files, then assign it to a variable. And it must use in this way. Dollar symbol followed by bracket, and in the bracket, the first place should be wildcard. You can see the example. So in this example, the source is a variable, and its value is all the files that have the extension of C. And the second kind of wildcard is a percentage symbol. Similar rules could be concluded in a pattern. We don't exclusively specify rules for main.o and func.o, but leave them to match this pattern. Because this pattern matches these two object files, so they can be extended to several rules. And now let's extend the pattern to the more specific rules. On the right, line 5 and line 6 could be extended as the image on the left. So if you compare these two images, you will find this pattern is very useful, especially when there are hundreds of object files need to make. And only when there is no explicit rule for a target, the pattern rule will be used. make will find the first pattern that matches the target. So if we have a pattern rule for main.o, and also there is an explicit rule for main.o, make will firstly use the explicit rule. And there is another syntax called substitute. The grammar is written above, and you can see the following example. It substitutes all the characters B and replace it by character C. So when we equal new, ACC will be printed. And similar, there is another syntax called pattern substitute. Instead of replacing character, this syntax replace patterns. It means to substitute all that match replacement, which is a pattern, by pattern in the text string. And here is an example. So if source is main.c, func.c, then object should be main.o, func.o. So in this way, we can derive all the object files with the same name as source files. Using wildcard and automatic variables, we can do a lot of interesting things. See this script. We define two variables, sources and objects. Sources represent all the source code file in the directory, and objects represent the object file compiled by the source code. And we want to make main. Can you tell how this makefile works? Let's see what happens if we directly execute the makefile. First, we just compile all the source code, and then we link them together and generate an executable file main. And we are doing this by only 10 lines of makefile. This is the powerful of automatic variables. Also, we can extend the project by adding more source files. And we simply make. We can rebuild the project automatically. Make works more than C program, but there are some implicit rules for C or C++. It is not recommended to use, but good to know when reading a makefile. Define these implicit variables, and these variables will be added automatically if we don't explicitly define a rule. And you can read the 6 implicit variables and what do they mean. Even the rules for main.o, func.o don't exist. The commands for main are not specified. These implicit rules provide default making rules for C, C++ programs. You can see the left image. In this makefile, we do not specify the command for main, and we do not specify the rules for these two object files. But it can also work because we define the implicit variables. Implicit rules are used when there are no explicit rules. And there are conditional statements in makefile. They are less frequently used, and they are mostly used for variables. This is an example of conditional if-else. It determines whether FOO equals to OK. And this example checks if a variable is empty. And this example checks if a variable is defined. And at last, there are phony targets. Phony targets are special targets. Make does not treat them as targeted files, but labels or actions, which means even there is a phony target called clean and a file called clean, make will also execute these commands. If we do not define a clean as a phony target, make won't execute if the file clean is up to date, because make will only make the targets that are not up to date. We define it as a phony target. It will make it anyway. The most important and the most commonly used phony target is clean. We can define a phony target by .phony, all capital letters. So there are some good practice when writing a makefile. Always use all, the extreme target, especially when there are more than one target need to made. Use automatic variables and have a phony target clean. After define a clean phony target, we can type make clean to remove all the object files, and always explicitly specify the commands instead of using implicit rules. So can you design or improve the makefile for your C or C++ project? If you want more resources, there are plenty of resources online. 3 of the websites, which I think them useful. To better illustrate how we write a makefile script, I'm going to show you with an example. And in this directory, there are 5 files, include the header files and the source code. And then let's check what they do. In main.c, it calls 2 functions. One is function1, and the second is myPrint. They are not built-in functions, and they are defined in the header files. And in the header files, we can see the header file just define the prototype for each function, but the implementations are in the source code. This is function1. It's really a simple function. Only return the argument +1 as the result. And myPrint is also a simple function. It just print a reminder message. This is myPrint, and finish. So even this project is simple, there are still many dependencies. In order to use make, we need a makefile script. So let's write makefile together. Assume the target executable file is called target. So target is what we want. And we need to create rule to build the target. Target need several object files, which are main.o, function1.o, and myPrint.o. These three object files are derived from the source code and header files. The command to build target can be derived easily. One single line is fine. We call GCC compiler to create target. This command is correct, but we can optimize it using automatic variables. So target can be replaced by $@, which refers to the target in line 3. And the following three object files, which is the prerequisites, can be replaced by $ and this symbol. So these two commands are exactly the same, but it would be better to use automatic variables. Why is that? Because we can change the target name to other, and we don't need to change the command. And we still don't have the rules for building these three object files. So we need to specify. Main.o need main.c and the two header files. And myPrint.h. The two header files are necessary because without them, we cannot get main.o. And how do we get this object file? we can still use the GCC compiler with argument C. And this automatic variable means the first prerequisite, which is main.c. And function1.o need function1.c and the header file. And the built-in command is the same as the main.o. And similarly, my print.o can be derived easily. In the end, it would be better and safe to create a phony target called clean. And clean is to remove all the object files and the target files. Okay, so we finished the writing of makefile. And let's see if it works. So the commands are echoed and printed to the screen in the sequence of the commands. You will find makefile are executed from the bottom to the top. Firstly, notice that the 3 object files are missing. So they will first make these 3 object files. Then it can make target. And we can run the target. So the project has been successfully made. What can we do to improve it? You may find the making rules for function1.o and myprint.o. They are similar. So how can we simplify the writing? Easy. We can use the wildcard symbol. This rule can be extended to these 2 rules, and they serve as the same function. So let's see, does it work successfully? First, clean all objects and make again. So this really works. Okay, and to see the powerful of makefile, we are going to change and modify one of the source code. Let's see function1. we want to modify the function. Let it return the result of x plus 2. And first, we need to clean the object. Otherwise, Make wouldn't update the project. Okay, and we make again. Make is a powerful tool to build a large project. Using Makefile is very convenient. Less than 100 lines of Makefile script can help you build a super large project. This is the powerful of Makefile, and this is the end of Make tutorial. Thank you.